All right, so here's lesson 3.8, part 2. Problem 4, of 30 students in student government, 20 are honor students, 9 are officers and honor students. All of the students are officers, honor students, or both. How many are officers but not honor students? Let's let H equals honor students. O can be officers. And H intersect O has, what did it say up there? 9 are officers and honor students, so there's 9 there. So we can go ahead and put that in the diagram right there. Only honor students, so that would be the ones, that'd be 20 minus the ones that are both, which would give us 11. Only honor students would be over here. Only officers would be 30 minus the ones we already have there. So that would be 30 minus 20, which is 10. And if we add all those up, we should get the total, which is 30 total. So the number of students who are officers but not honor students, officers but not honor students, that would be those 10. All right. Okay, what are the solutions of the absolute value of the quantity 2x minus 1 is less than 5? Write the solutions as either the union or the intersection of two sets. So we're going to write this as sets once we figure out what it is. Now remember, if the absolute value of 2x plus 1 is less than 5, that means on a number line, just to review, either 2x minus 1 has to be less than 5 units away. 2x minus 1 has to be within this range. So it has to be 2x minus 1 has to be less than 5, and 2x minus 1 has to be greater than negative 5 to be true. So we have 2 things we need to solve here. And if we want, we could write it as one complex or compound inequality. You guys are probably thinking these are complex, but so 2x minus 1, we have to put that between 5 and negative 5 for the absolute value to be less than 5, or the distance from the origin to be less than 5. So let's add 1 to everything, and we get negative 5 is less than, negative 4 is less than 2x, is less than 6, and we can divide everything by 2. And we get negative 2 is less than x is less than 3. So x must be between negative 2 and 3. Now we were supposed to write that as the intersection of 2 sets. So what we have here is all numbers that are greater than negative 2 and at the same time less than 3. So we're going to use set builder notation. We're going to say x such that x is greater than negative 2, like that. And we're going to intersect that, since it's an and, with all numbers such that the numbers are less than 3. And that's what that looks like. So if we solve this compound inequality, and we're going to think of it as either the union or the intersection. If it's an and, then it's an intersection. If it's an or, then it's a union. So what is the first step in solving this inequality? I'd say we should subtract 5 from each expression. Let's circle this one. When you isolate the variable, inequality becomes if we subtract 5 from a equals 3, if we subtract 5 from x plus 5, we get x, and if we subtract 5 from 11, we get 6. So we get x, we get 3 is less than or equal to 6, x, and x is less than 6. Now write the solutions. The inequality is either the union or intersection, so x is greater than or equal to 3. 3 is less than or equal to all numbers, and all numbers less than 6. So I was just thinking about that on a number line. So let's think of this here, and let's say that 6 is out there, so we have all these numbers less than 6, so that would be that way. And then we have all numbers greater than or equal to 3, that would be in here. That would be that way. So the intersection is that little area between them. So this is an intersection of two things, part of each of those sets. All right. So the lesson check, right? The statement describes a union, right? I describes an intersection. It contains elements that belong to either set or both sets. That would be the union. In a Venn diagram, it is the part of the circles that overlap. That would be the intersection. The way that they are similar is that both unions and intersections have elements that belong to either, or have elements that belong to both. So I'm going to write it this way: unions and intersections have elements that belong to either. And they are different in that unions also have elements from both sets, or from elements that can just be in one or the other. I guess I should change that word to both. From either one or the other. All right. I'll see you tomorrow.